Welcome back to Zone for Geeks. My name is Casey, and today we are going to take a step back and talk about basic networking. Specifically, we're going to look at how frames traverse across a network. Go ahead and take a look at our network. You can see we have a media server here, a laptop here, and a gaming system and a few phones over there. They are all connected by a switch, which we see here in the center. For the purposes of this video, this switch has both wired and wireless capability. Now, let's say, just for the sake of argument, that we've just built our media server. We've given our server an IP address of 192.168.1.100 with a subnet mask of 255.255.255.0. We've added our favorite shows and movies, and now we want to connect our media server and watch a little TV. The question becomes, how can our computers, smart TVs, phones, and other devices find our brand new media server? First, we start with our client machine. In this case, our client is the machine or device that is making the request. In our diagram here, our client is the laptop computer. The first thing that happens after we open our web browser and type in the IP address of our server is for our laptop to check and see if it knows where to find our server. To do this, it checks this ARP table. ARP stands for Address Resolution Protocol, and it's used to map IP addresses to MAC addresses. The ARP table contains a list of known IP to MAC addresses. On Windows, to see the ARP table, you use the command ARP-A in the command prompt. You will notice that our media server is not listed. In our scenario, since our media server is a brand new device on the network, our laptop doesn't have a record of the MAC address. Since it doesn't know where our media server is, our client will send out an ARP request on the broadcast domain. Since we are using a /24 network, the request is sent out using the IP address 192.168.1.255. Since our ARP request is using the broadcast IP, that request is going to go to every device on our network. Only the computer or device with the IP address of 192.168.1.100 will respond to the ARP request. Once our media server receives the ARP request, it sends a response back. Within this data frame is the MAC address of the media server. Now, on its way back to our laptop, the data frame passes through our switch, which will automatically update its own MAC address table to include any changes that need to be made. This happens whenever traffic passes through a switch. The switch will record the MAC address as well as the port associated with that MAC address. Now, no matter which device tries to access our media server, the switch knows exactly where to send the traffic. Our ARP request leaves the switch and goes back to our client machine, where our laptop updates its own ARP table with the media server's IP and MAC address. Now that our laptop knows where our media server is located, when we try to access our media center the next time, our laptop will consult the ARP table and then send out the data frame that contains the source MAC, our laptop, and the destination MAC, which is our media server. The frame reaches our switch, which checks its MAC table. Finding the MAC address in its MAC table, the switch sends the traffic out through the appropriate port. Once the media server receives the frame, the transmission is over. Of course, most network communication is back and forth, so this process repeats as our media server sends and receives data frames. And that's how traffic flows across your network. This is my first animated video, so if you want to see more, give me a thumbs up and hit that subscribe button. Thanks for watching, and I'll catch you on the next one.